I'm fine. I'm not sick.
Mom, shut up. You're seriously sick and you need to see a doctor. This
No.
is only going to help.
No. I'm going to miss tonight's episode of The Bachelor.
Hi, what seems to be the problem here?
My son seems to think that a little diarrhea and vomiting is an excuse to miss The Bachelor.
My mother has had severe diarrhea and can't keep her food down for about a week. Can you help?
Yes, of course we can help, but how long has this been happening?
It doesn't matter. The Bachelor is on tonight, so it doesn't matter.
This has been going on for about a week.
Okay, well, I'm gonna go consult with another doctor and come up with a plan of action, and we'll be back shortly to explain.
Hello, I'm the other doctor that was consulted. We've determined that you're dehydrated.
Yes, you've lost a lot of fluids over the past week, so we need to get them all back into your system.
Well, just put some water in a bag and shove it in my arm so I can get home and watch The Bachelor.
Well, it's a tad more complicated than that. We can't give you pure water because it'll kill you.
You're just saying that because you want my money, you want to waste my time, and you want to keep me away from The Bachelor.
No, ma'am, actually she's telling the truth. If we give you pure water, your cells will take it all in and become lice, so that's called a hypotonic solution.
Well then, what do I do?
We'll give you some water, but add salt to it. It has to be as close to 0.9% because of your red blood cells.
Yes, if we add too much salt, then it'll be a hypertonic solution. A hypertonic solution is when water is drawn out of the cell. So this causes the cell to shrivel up and go through crenation, which can again result in death.
By getting the solution to 0.9%, we're attempting to create an isotonic solution. An isotonic solution is a balanced solution between salt and water. It'll keep the cell at the same size and shape.
Well, that all sounds great, but how exactly does the cell shrivel or pop?
Well, see, that's a simple explanation actually. Water follows the salt, so if the solution has more salt on the outside of the cell, the water will follow to the outside and it actually dehydrates you more.
If there isn't enough salt in the solution, the water will go inside the cell and the cell will pop.
That all sounds good, but I'd really like to see a visualization of it.
Mom, why? Didn't you want to go home?
I'm trying to get better. Isn't that what you wanted?
We can run an experiment and get the results in about 48 hours, and then a nurse will come in and administer the IV.
The experiment began with a potato. It was cut into 3 equal parts. Each part weighed 2.7 grams. 3 cups were then separated. One was hypotonic solution, 100 milliliters of water, our pure water example. The second was isotonic with 90 mLs and 10 grams of salt, our 0.9 example. And the third was hypertonic with 70 milliliters of water and 30 grams of salt. We measured out the water using a graduated cylinder. We then put 1 piece of the potato into each one of the cups and waited 48 hours to find our results. After the 48 hours were concluded, we showed our results on a data table. Isotonic, the potato weight changed from 2.7 grams to 3.1. In the hypotonic solution, it changed from 2.7 to 4.0 grams. And in the hypertonic solution, it changed from 2.7 to 2.5 grams in potato weight. In this graph, the potato weight change is demonstrated. The weight before, 2.7 grams, is demonstrated in blue, and the after results are demonstrated in orange. As you can see, the weight of the potato increased for each solution. In this graph, you can see the potato water change. Science tells us that if the weight of the potato increased, the water level is going to decrease. This is demonstrated in the graph, as the blue represents before and the orange represents after. There's a drastic decrease in the water levels after the potato had been in the solution for 48 hours. The results of the experiment did experience some errors. In the perfect experiment, the isotonic results would have been the same as water flowed in and out of the potato the same way. The hypotonic solution would have increased the weight and decreased in water because the potato would have lysed or drawn in water and expanded and gained weight. The hypertonic solution weight should have dropped and water increased as water left the potato and was drawn towards the salt. This process is known as crenation. Science tells us that water follows the solute, meaning the water follows the salt. So wherever there is more salt, the water will go. This means that in a hypertonic solution, the water would have left the potato going to the salt that was on the outside of the potato, causing the potato to shrivel up. Let's go give our results to our patient.
Wow, that was really informative. Thank you.
Thank you for helping my mom. Are you happy you came?
I'm still mad that I missed the bachelor, but I'm glad I got a science lesson.
Well, I don't think the bachelor is as important as your life, but I'm glad we could help.
Hello. I'm not
Mom, why?